All right, guys. So a very good evening to you all. So let's continue with our today's lecture. Now, I think the last thing in your notebook must be this particular question where we have studied the various stages of program development. Now, today we'll start with a difficult and an important topic called algorithm and flowchart. So what you do is give this as the heading, okay? Copy everything which you see in front of you. That means you'll copy developing algorithm and flowchart, refer PN 8 to 13. Under that, a subheading algorithm, okay? I hope you remember PN stands for what? So PN stands for printed notes. So come on, copy all this. Do that quickly. Come on. All right, guys. So let's understand what is an algorithm. So today, first we'll be studying an algorithm and then a flowchart. In your exam, you'll have questions like these. Write an algorithm to find the sum of first 100 natural numbers. Write an algorithm to find the roots of a quadratic equation. Draw a flowchart to check whether a given number is prime or not. So now let's understand what is an algorithm and what is a flowchart. First of all, write definition of an algorithm. Come on, so write the definition, right? An algorithm is an English-like representation of the program. I repeat, an algorithm is English-like representation of the program. All right. Now, guys, what we'll do is we'll spend 5 minutes to understand what exactly this definition means. Okay. So please be very attentive because things are going to be slightly difficult. Now, let's say you have this question in front of you. The question is telling you, write a program, not write an algorithm, write a program to display maximum of two given unequal numbers. Now, whenever you have a programming question or an algorithm, the most important thing is that you understand the question. Because if you don't understand the question, you will obviously not be able to answer the question. So over here, we are supposed to write a program. What this program will do is it will take two unequal numbers from the user. So let's say the user enters 5 and 7. And then our program will display the maximum of these two numbers. So that will be 7 in this particular case. Okay. Now what we'll do is we'll write this program in C language. Now some of you must be wondering that we hardly know anything about programming. So how can we write the program over here? So let me tell you one thing right now. In the next 5 minutes, our intention is not to understand the syntax of the C language and the various programming constructs of the C language. Our intention is to understand the definition of the algorithm. So whatever we are doing in the next 5-10 minutes, it is to understand the definition of the algorithm. So there will be many things which you will not understand, which is okay. All right, let's start. So as usual, if you remember, we'll start with hash include stdio.h, where stdio.h is a header file. Then we'll write void main. You can also write int main if you're using code blocks, that's okay. Now, what I will do is I'll write something called int a comma b. Now, in tomorrow's lecture, we'll study about this in great detail. For time being, just understand that over here, I'm creating two variables, a and b, and a and b will be storing integers. Okay. Anyway, so it means this statement means that a and b are variables. There are some elements, and they can store integers. Once again, don't think too much about the details over here. We'll study this in great detail tomorrow. After that, what we will do is we'll write a printf statement. Now you had studied printf last week. So what this printf will do is on the monitor, it will display enter two unequal numbers. Now, when you go to the ATM machine, the ATM machine tells you enter your PIN. Now, when it says enter your PIN, what do you do? What you do is on the keyboard, you press the keys of your PIN. So the same thing the user will do over here. The user will type two unequal numbers. Now what we want to do is we want to take these two numbers from the user and we want to store these two numbers in variables A and B. So for that, we'll write a scanf statement. Now, right now, don't get intimidated. Don't get scared of the syntax, %d, %d, double quotes. We'll study all this in great detail in chapter 4. Right now, just understand one thing, that when you write this statement, A will get the first number which the user has typed on the keyboard, and B will get the second number which the user has typed on the keyboard. Now, let's say the user has typed 5 and after that 7. So now what will happen is 5 will be given to A and 7 will be given to B. 5 to A and 7 to B. Now we'll write one if statement where if statement will check if A greater than B. Okay. So now this is quite obvious. Here we are checking who is greater. Is A greater than B? So if A is greater than B, whom should we display on the monitor? Obviously A. So we will just write printf %d A. All right. So when you write printf %d A on the monitor, the value of A will be displayed. Now let's say B is greater than A. Let's say B is greater than A. So this condition will be false. So for that, we'll write else. And under else, can you take a guess what statement is going to come? If you take this guess, that means you are understanding this properly. Well, you can unmute yourself and you can take a guess. It's better to give me a wrong answer instead of keeping quiet. Can you take a guess?
B is greater than A.
%d and B.
Very good. The second answer, second guy, you're correct. So over here, we'll write printf %d B. So which means now B, the value of B will be displayed on the monitor. And now I'll close the brace. So when I close the brace, that means the program ends over here. Now, as I told you, our intention over here is not to understand the scanf, printf, all this. Our intention over here is to understand the definition of algorithm, which we'll do that very soon. Okay, so right now, don't get scared of all this. Now, what you see in black color over here, see the color properly. Okay, we'll use lots of colors and the colors will make your life simple. So the black color over here is C language, Now let's write the same program in C++. Although C++ is not there for many of you, okay, but still let's write the same program in C++. So in C++, instead of writing hash include stdio.h, we'll write hash include iostream.h. Instead of writing printf, we will write cout. Okay. Instead of writing scanf, we'll write cin. See to it that over here, this thing is in double quotes. So whatever you write in double quotes will be displayed as it is. Now over here, as I told you, instead of printf, we'll write cout. But now we'll write just cout A. See to it that is A is not in double quotes. So its value will be displayed. So now take a guess. What will I write over here? Come on, simple. Unmute yourself and tell me what will I write over here?
Cout B.
Very good. Cout B is the answer over here. Okay. So once again, now on this screen, what you see in black color is C. What you see in red color is C++. Now I am going to write the same program in one more language. Come on, now can you take a guess? Okay, let it be fun. Can you take a guess in which language am I going to write the same program the third time? Come on, give me the answer. What language? It's a guess. Come on, tell me it's okay.
Python.
Okay, one is Python.
Python.
Huh?
Java.
Any other answer?
Java.
Algorithm.
Pardon? The last answer, the last guy, what did you say? Okay,
Algorithm.
so yeah, very good. So now what I'm going to do is I am going to write the same program in English language. I repeat, English language. Okay. So now when I write this program in English language, for everything till here, see where my mouse cursor is. For everything till here, till this int a comma b, I will just write start. Okay. So this start is for everything till here. Okay. Now this printf and scanf, okay, this printf and scanf, what work they do together? So do one thing, ask yourself in English language. In your mind, ask yourself in English language that printf and scanf, what work they are doing together. Can you give me the answer?
Input.
Pardon?
Put.
Very good, but can you frame it in words? You are
Input for
correct.
two numbers.
Pardon?
Input for two numbers.
Very good. So now what I will do is, whatever work printf and scanf are doing, I will frame it in English words, and that is step number 2. I'll write read two unequal numbers as A and B. So what I'm doing is I'm telling the computer that, look computer, you are supposed to read two unequal numbers, and those two unequal numbers will be stored in A and B. Now, after that, this part is very simple. I don't even need to explain. If you just read it carefully, you'll understand. Step number 3 says, if A is greater than B, go to step 4, else go to step 5. So can you take a guess what will be step number 4?
Print A.
Very good. Step number 5?
Print B.
Very good. So step number 4 is display A. You can also write print A, show A, it's okay. And then display B, step number 5. And finally, we will stop. Now, once again, okay, now I want everybody to give me the next set of answers together. My questions are very simple. I want everybody to give me the answer together. All right. So unmute yourself and give me the answer. So what you see in black color is which language?
C.
C language.
Correct. Red color?
C++.
Very good. Blue color?
English.
English language. And the blue color is the algorithm. Now I will read the definition of the algorithm, and with me you will also read that definition in your mind. So the definition of algorithm says an algorithm is an English-like representation of the program. So what happens is, see my mouse cursor, this is the program. So whenever we write the steps of the program in English-like language, that becomes an algorithm. Okay. Now, very quickly, I'll also tell you the advantage of algorithm, although nobody will ask you this in exam, but being programmers, you should know this. See, the purpose of writing an algorithm is that when you write an algorithm, you are not burdened with the syntax of the language. Okay, you don't need to take care of the language and its syntax. That means you don't need to write this void main, parenthesis, brace. Okay, you don't need to write this int ab. Instead of writing display, you can write show. Instead of writing something like read two unequal numbers, you can write input two unequal numbers, something like that. So when we write an algorithm, our focus is on the logic and not on the syntax. Okay, our focus is on getting things done, not on how to get those things done. Okay, so basically we don't want to be burdened with the syntax of the language, and that is the purpose of writing an algorithm. Okay, anyway, so now I hope you understood the definition of the algorithm, which says that algorithm is an English-like representation of the program. Okay, now this is the first question which we'll do today, which says write an algorithm to find maximum of two given unequal numbers. So if you have been attentive, tell me, have I ever taught you this algorithm? Unmute and answer. Have I ever taught you this algorithm?
The last algorithm.
Yes, it is the same algorithm which you saw in blue color just now, the same thing. This is an algorithm to find maximum of two given unequal numbers, same thing. So every algorithm, the first step will be start, the last step will be stop. Okay. After that, here we are reading two unequal numbers as A and B. We are checking which is greater, and accordingly we are displaying A or displaying B. All right. Now I will convince you how difficult logic is. If you have been taking programming lightly, now I'll convince you how difficult programming is. Now, this is a very, 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 very simple algorithm. You will probably never get it in your exam. But in this simple algorithm also, there is one mistake. There is one mistake. Now, if you are able to answer that mistake, okay, that means you are very attentive. And last to last, first lecture, I think I told you that I used to give in my physical classrooms, I used to give chocolates for some questions. So this was my chocolate question, okay? The one who used to answer this used to get a chocolate. Anyway, so unmute yourself and try and tell me, do you see a mistake in this algorithm?
There is nothing about if B is greater than A.
Pardon? Can you speak a bit louder, please?
There is nothing about if B is greater than A. No
No, that is
statement about it.
taken by else. That else means that BB is greater than A. Anything else?
What if the user inputs both the A and B value same?
See, that we are not bothered because the question right now says maximum of 2 given unequal numbers. So the question itself tells you that the numbers will be unequal. So as of now, we are not bothered, but very good. Anything else?
Considered as greater, but if B is considered greater, then display B will come first. No.
Can you repeat again?
Here A is taken greater than B,
Uh-huh.
so there is a line of display A first.
Hmm.
But if B be greater, then display B will be first. No.
You are partially correct, but still very good. Okay, see, now listen to me very, very, very carefully. If you are answering the next question, okay, I'm going to ask you all a question after 2-3 minutes. And if you answer the next question wrong, that means you are thinking too much. I often tell my students that if you want to make programming easier, think less. Okay, think to the point. Okay, so now I'll come to know about it after 2-3 minutes. Okay, now listen to me carefully. Now, step number 1 says start, and step number 2 says read two unequal numbers as A and B. Now, let's say the user gives two unequal numbers, 7 and 5. I repeat, 7 and 5. Okay. If the user says 7 and 5, okay, step number 3, it says if A greater than B, go to step 4. Okay. Let's say the user gives 5 and 7. I'm sorry. Once again, I'll repeat. Step number 1 is start. Step number 2 says read two unequal numbers as A and B. And let's say the user enters 5 and 7. I repeat, 5 and 7. So B is 7, A is 5. Now it says if A is greater than B, go to step 4, else go to step 5. Okay. Now I've explained you till here. Now I want you guys to tell me one thing. If A is 5 and B is 7, will our algorithm work correctly? Everybody answer the question. You just have to say yes or no. Will our algorithm work correctly if A is 5 and B is 7? Tell me. Giving a wrong answer is better than saying nothing. And as it is, you're not physically in front of me, so don't hesitate to give me the answer. It's okay.
No.
You just have to say yes or no.
No, sir.
Other answer?
No.
No.
A5, B7. Will it work correctly?
Yes.
Okay.
Yes, sir.
So my answer is yes, it will work correctly. How it will work correctly, I'll tell you. But my suggestion to those people who said no, first of all, I'll compliment you that you gave the answer. So it's a very good thing. But what happens is the moment I said 10 minutes back, when I said that this algorithm is wrong, okay, you started thinking on those lines that the algorithm is wrong, okay. But in programming, you have to be very precise. You have to be very accurate. So right now, the answer is yes. Right now, it will work correctly, okay. Now, how it will work correctly? So listen, if A greater than B, go to step 4, else go to step 5, okay. So now, we will go to step number 5. Step number 5 will display the value of B, which is 7. And after that, step number 6 stops the algorithm. So here, our algorithm works correctly by displaying 7. The algorithm will not work correctly if the user has entered 7, 5. Now let's consider that case also. Step number 1 is start. Step number 2 says read two unequal numbers as A and B. So let's say the user has entered 7 and 5. So A is 7, B is 5. Now, is A greater than B? The answer is true. Yes, A is greater than B. So we'll go to step 4, and step 4 will display the value of A, which is 7. Now, I think everybody should tell me what is the problem now.
Next step will come.
The problem over here is after displaying A, okay, logically step number 5 will execute. So step number 5 will also display B, which is equal to the second value, which is 5. So the problem occurs in this algorithm if A is greater than B. If A is greater than B, then our algorithm is displaying both A as well as B, and this is the mistake in our algorithm. Now, if you want to become a programmer, you need common sense. Or I will say this way, if you want to become a programmer, you need to develop your logic. And for developing your logic, all you need is common sense. That's it, nothing else. Okay. So come on, use your common sense and tell me, how will you prevent going to step number 5 in this case? Very simple question. How will you prevent going to step number 5 in this case? Very simple. Come on, answer the question. Anybody?
If A is greater than B, go to step 4 and skip step 5.
Very good. So what we can do is, after writing step number 4, or I will say at the end of step number 4, I will just write go to step 6. So what will happen? Display A will execute, and go to step 6 will effectively skip step number 5, which is display B. Now, my last question over here, I want everybody to answer this question. Okay. Now let's say I write go to step 6 over here. Okay. Now, if I write go to step 6 over here, it is correct. I am telling you it is correct. But my question to you is it required? So your answer should be yes or no. Everybody should answer this question. Yes or no?
No.
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 No. The correct answer is no. It is not required. But even if I write it, it's okay. No problem at all. So now this completes our first algorithm. Now before we go to the next one, any doubts over here? Any doubts? Okay, so I want everybody to copy this algorithm. First copy the question and then copy the algorithm. Copy everything which you see on the screen. I give you 1 minute for that. Be fast, come on. Have you finished? Okay, let's go to the next algorithm. So now copy Then next question. Now things will become more and more difficult and interesting. So now everybody copy this question. While copying the question, pay attention to what you're copying. Come on, copy the question. Write an algorithm to find the sum of first 100 natural numbers. Come on, copy the question. Write an algorithm to find the sum of first 100 natural numbers. Okay, now first let's understand the question. If you don't understand the question, then you will never be able to solve that particular question. So let's understand the question. The question says write an algorithm to find sum of first 100 natural numbers. So answer a very simple question. What are the first 100 natural numbers? Tell me. Tell me which are the first 100 natural numbers. Please tell me.
1 to 100.
1 to 100.
Yeah, 1 to 100. Okay. So basically what you need to do over here is you need to find the sum of these numbers. So you need to find 1 plus 2 plus 3 plus, and that way the summation till 100. Now this is what you are supposed to find. Now answer a very simple question. What is the sum of first 3 numbers? Please answer the question. Everybody?
6.
Pardon? How much?
6.
6. Okay. So the way the sum of first 3 numbers is 6. That way we are supposed to find the sum of first 100 natural numbers. Basically this value we are supposed to find out. Now let's see how we do that. We are going to study many new things over here. Be attentive. Things are interesting, but things are difficult. Okay. Sorry. Now in every algorithm, step number 1, just a minute. In every algorithm, step number 1 will be start and the last step will be stop. Okay, so that is step number 1 and the last step. Now read step number 2, which says initialize sum to 0 and I to 1. Now let's talk a little about step number 2. This step number 2 is called initialization. I repeat, this step is called initialization, and over here sum and I are variables. Now I hope you remember you have studied algebra in your school. Now when you do algebra, in algebra you use many variables to store values. So the way we have variables in algebra, that way we have variables in programming also. So sum and I are basically 2 variables, and over here these variables will store some values. Now this arrow over here is similar to equal to symbol. So what you could have done is you could have written this way also: initialize sum equal to 0 and I equal to 1. Okay. Now you may ask me why I am writing arrow over here. So what happens is in many textbooks, what happens is in algorithms, they often replace this equal to by arrow symbol. And because textbooks have this arrow symbol, many college teachers also use the arrow symbol over here. So only for your convenience, I gave the arrow over here. If your college teacher uses equal to, then you also write equal to over here. So basically, we have created 2 variables, sum and I. And currently sum is initialized to 0 and I is initialized to 1. Now some of you may have a question in your mind, and the question could be why we have initialized sum to 0 and I to 1. So the answer is why we have initialized sum to 0 and I to 1. That I will give you at the very end of the algorithm, after the entire algorithm is over. For time being, just understand one thing, that is sum is going to store the final answer. So in the end, the sum will be equal to the sum of first 100 natural numbers. And what is this I, that you will understand on your own very soon. Now this is step number 2. Now let me write step number 4 and 5. So step number 4 will be compute sum equal to sum plus I. Instead of writing compute, we could have written calculate also. Okay, or even if you don't write any word over here, it's okay. So basically, we are supposed to execute one equation which says sum is equal to sum plus I, and compute I is equal to I plus 1. Now, in step number 3, I will write that execute steps 4 and 5 100 times and then go to step 6. So step number 3 is kind of controlling step number 4 and 5. It is telling step number 4 and 5 to execute 100 times, and only then you go to step 6. Okay. I'm sorry. So now let's understand how this works. Now, in order to explain this logic to you, I will draw a table over here. So this is a table. So in this table, I have two variables. Okay, variable I, and variable sum, which is initialized to 0, Okay. Now, in the beginning, let's start from the beginning. Step number 1 is start. Step number 2 says initialize sum to 0 and I to 1. So look, sum is equal to 0 and I is equal to 1. So I wrote I is equal to 1 here. Now it says execute steps 4 and 5 100 times and then go to step 6. So now let's execute. Let's run step number 4 for the first time. So it says compute sum is equal to old sum plus I. Now answer a very simple question. In algebra, when you write sum is equal to sum plus I. By the way, keep looking at this small dot over here. I hope you see it moving under the arrow, sum plus I. So under the arrow, there is a small dot. So keep looking at that, please. Okay. Now answer a very simple question. When we write such expressions, this sum is considered to be the new sum or the old sum? Come on, unmute and answer.
New.
New sum. New.
And this one?
New.
Old.
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 Okay.
Old.
So you know which is new, which is old. So that makes my work a little easier. So now, okay. So now the new sum is equal to old sum plus I. So now listen to how I am reading this particular expression, and here onwards you will read it in the same way. Okay, listen to how I'm reading it. Sum is equal to 0 plus 1 equal to 1. So the new sum is equal to 0 plus 1 is equal to 1. Okay. Compute I is equal to I plus 1. So the old I is 1. So the new I is equal to the old I, that is 1, plus 1, which is equal to 2. So what we have done is we have executed step number 4 and 5 one time. Now answer a simple question. Okay, everybody, all right, unmute yourself and tell me, after the first execution, what is the value of sum? So simple. The answer is in front of you. What is the value of sum?
1.
Very good. What is the value of I?
2.
2. Very good. The value of I is 2. Now I will execute step number 4 and 5 second time. Okay. And this time I want you all to read with me, and you will read it in this manner. First listen this way. Sum equal to 8 plus 2 equal to 10. I just gave you an example. Okay. So you will read it in this manner. Sum is equal to 8 plus 2 equal to 10. So come on. Now let's read it together. Sum equal to, tell me.
1 plus 2.
Very good. 1 plus 2 equal to 3. So this will become this way. New sum is equal to old sum, which is 1, plus I, which is 2, which is equal to 3. Okay. Now compute I is equal to I plus 1. So that is very simple. The old I is 2. So the new I is equal to 2 plus 1, which is equal to 3. Now a simple question. Till now, we have executed step number 4 and 5 how many times? Tell me.
2 times.
Very good. 2 times. We have executed 2 times. Now let's execute them last time, that is third time. Okay, although we are supposed to execute 100 times, but 100 is too big for us. So let's execute third time, last time. Come on, once again, you all will tell with me. Sum equal to, come on, tell me. Sum equal to, come on, tell me.
3 plus 3 is equal to 1.
Very good. Sum is equal to old sum, which is 3, plus I, which is 3, which is equal to 6. So the new sum is 6. I is equal to I plus 1, and that is equal to 4. Now, I am pretty sure everybody understood this. Now, understand why we did all this. Once again, answer a very simple question. We have executed step number 4 and step number 5 how many times?
3 times.
3 times. 3 times individually. 3 times we have executed step number 4. 3 times we have executed step number 5. Now, if you look at this working a little carefully, you will realize something is happening over here. After 3 executions, I repeat, after 3 executions, sum takes the final value 6. Now, can you tell me what is this 6? What is 6?
Sum of first three natural numbers.
Very good. This 6 is basically the sum of first 3 natural numbers. So try to understand what happened over here. When we execute step number 4 and 5 3 times, all right, you get the sum of first 100 natural numbers, first 3 natural numbers. So if I execute step number 4 and step number 5 100 times, you will get the sum of first 100 natural numbers, and that sum will be stored obviously in variable sum. So now come on, take a guess, what will be step number 6? Very simple, step number 6.
Display sum.
Very good. The answer will be display sum. Why? Because the answer is stored in variable sum. Okay. So guys, this was the logic of finding the sum of first 100 natural numbers. Now, while I was explaining this, many of you may be having one doubt in your mind, one question in your mind, and that question could be that although you understood this, you will wonder in your mind that how this logic will strike you. I repeat, some of you must be thinking in your mind that I have understood this, but how this logic will strike me in exam? So guys, the only answer for that question is practice. Okay, you will not become a programmer in one day, in 1 week, in 1 month. You need to keep practicing a lot with me. Okay, I'll give you some homework questions. You need to solve those homework questions, although the homework will not be compulsory. But if you do that homework sincerely, okay, if you keep practicing, then one day your logic will be developed and you will become a programmer. And this problem which I spoke about just now, that how will this logic strike me? Okay, this problem is common with everybody, not only you. So in the beginning, it is important that you understand what I am teaching you and keep practicing along with me. Anyway, now one question is remaining to be answered, and that question is 1 minute. So that question is that, just a second guys. Okay, so that question is, why initialize sum to 0 and I to 1? Why initialize sum to 0 and I to 1? So I'll answer this question, but first of all, what you do is, listen to me carefully, you copy this algorithm, you copy this working, and here onwards you should always copy this working, even if I don't tell you. Okay, the working is more important than the algorithm. You should give this working in exam also if you have time. So copy the algorithm, copy the working, and also copy this question. So after that, I'll explain you why to initialize. Okay, for time being, copy everything you see in front of you. I give you 1 minute, increase your speed of writing. Come on, be fast. All right, 1 minute is over, but I'll give you some more time. Be fast.
Sir,
Tell me.
sir, like in sum of first n natural number is n into n plus 1 by 2 तो कुछ ऐसा यूज कर सकते हैं क्या इसमें?
हाँ, क्या होता है ना, देखो, योर क्वेश्चन इज अ वैलिड क्वेश्चन कि डायरेक्टली फॉर्मूला यूज क्यों नहीं करने का, बट क्या होगा ना, देयर विल बी मेनी 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 प्रॉब्लम्स फॉर विच देयर विल बी नो रेडीमेड फॉर्मूला. So as far as possible, we should try avoiding the formula and use our own logic, our own steps. Moreover, क्या होगा ना, अगर formula use करेंगे, if you use formulas, some teachers may not give you marks. So these are the two reasons why we don't use that formula. Okay. All right, let's move ahead. Now I'm going to explain you that why did we initialize sum to 0 and why did we initialize I to 1. And whatever I'm explaining you, you will write the answer in your own words. I will not dictate anything. You will write the answer in your own words. So listen. The first thing is that when we write programs, in your programs also will be using variables. Don't forget that every algorithm is a program written in English language. So this is basically a program which you wrote in English. So in your program also you will be using variables. Okay. Now what happens is that when you use variables, you should give it some initial value. Okay, it is a rule of every language, whether it is C or Java or Python, that whenever you use any variable, you have to give it some initial value. So till here you have understood that you need to give some initial value to a variable. Now the first question in your mind could be, okay, so why I is initialized to 1? So that answer is very simple. We are supposed to find the sum of the first 100 natural numbers. So I'm sorry. So tell me, which is the first natural number? Tell me, everybody.
1.
1.
Second natural number.
2.
Third natural number.
3.
So if you look at this column a little carefully, this column, you will realize I is taking that natural number one by one. So initially I was 1, then 2, then 3, then 4, and so on. So because natural numbers start with 1, that is why I was initialized to 1. That is the simple answer. Let's say, okay, let's say tomorrow mathematics changes. Let's say tomorrow mathematics changes and mathematics tells us that now natural numbers start with 7. So tell me one thing, now you will initialize I with what value?
7.
7, as simple as that. Okay, so basically I is the natural number and natural number starts with 1. That is why I was initialized with 1. Now this question is interesting. Why sum was initialized to 0? So listen. Now I will ask you a question over here. Okay, and if you answer this question, that means you are very attentive. Let's say I initialize sum to 78. Let's say I initialize sum to 78. Okay, we need to initialize it to some value. So I initialize it to 78. Tell me what is the problem. It's very simple. The answer is in front of you actually. If I initialize sum to, tell me.
0 plus 78 will become 78. That is 78 से start होएगा. See, 78, 79.
The problem lies over here. See here. We are doing this sum is initialized to 0 in our case. But if sum is initialized to 78, then 78 plus 1 will be 79. 79 plus 2 will be 81. Okay. 81 plus 3 will be 84. So basically, we'll get the wrong answer. So understand one thing. Listen to my next statement. My next statement is very simple and mathematics. 0 does not affect the result of addition. I repeat, 0 does not affect the result of addition. That means if you add 0 to any number, you get the same number as answer. And that is why here onwards, make a rule that in programming, sum is always initialized to 0. Whenever you want to find sum of any damn thing, it is initialized to 0. So now, again, I give you some time in your own words. Write the answer why I was initialized to 1 and sum was initialized to 0. And if you have any doubt, you can ask me. Come on, start writing. If you have a doubt, unmute and ask.
सर इस क्वेश्चन में हम लोग इवन और ऑड का कंसेप्ट लेके नहीं सॉल्व कर सकते.
इवन और ऑड का इधर जरूरत नहीं है. वैसे मैं तुमको होमवर्क क्वेश्चन देने वाला हूँ और उस होमवर्क क्वेश्चन में हम लोग इवन ऑड करने वाले हैं. वी आर गोइंग टू डू इवन ऑड इन द होमवर्क क्वेश्चन. बट यहाँ उसका जरूरत ही नहीं है ना, क्योंकि नेचुरल नंबर्स में इवन भी आता है ऑड भी आता है, तो हम उसको कॉम्प्लिकेट क्यों करें.
ओके
ओके, ऑलराइट.
Sir,
Yeah, tell me.
if the question would be find the sum of first 100 whole numbers, then I would be 0.
Yes. But that will anyway not affect the addition because 0 plus again anything is same. But still, yeah, you can start with 0.
सर अगर सब्ट्रैक्शन करेगा तो अफेक्ट पड़ेगा ना.
क्या रहेगा नहीं, क्वेश्चन क्या रहेगा बोलो.
मतलब सब्ट्रैक्शन अगर रहेगा, वो सम की जगह पे सब्ट्रैक्ट करके पूछा रहेगा.
क्वेश्चन बोलो तो फिर मैं बताओ.
क्वेश्चन,
क्योंकि सब्ट्रैक्शन का कोई क्वेश्चन ही नहीं बनेगा ना, इसलिए मैं तुमको बोल रहा हूँ क्वेश्चन बोलो.
अच्छा हाँ.
Okay, let's move ahead. Now, everybody, what you do is you just write a big or, O-R, or. What we are going to do is we are going to write the same algorithm in slightly different way. So just write O-R, or. A big O-R, or. Okay, so now we have the same question. See, this is the same question. Write an algorithm to find sum of first 100 natural numbers. Same question, okay? Now listen to this carefully. I'm about to introduce something very important. Okay, listen. Now, over here, step number 4 and 5 execute 100 times, and step number 3 controls them, okay? So step number 3, 4, 5 together, step number 3, 4, 5 together, they constitute a loop. Now, if you ask me that show a loop with a hand, so I would say something like this. This is a loop, okay? So the point I'm trying to make is whenever in a program, if something executes again and again multiple times, we call it a loop. So step number 3, 4, 5 together, they constitute one loop. Now what happens is, listen to this carefully. I'm about to introduce something new to you, and this will be helpful in programs. Now what happens is when we write a C program, we will not be able to write step number 3 this way. No, this will not be allowed in any programming language, especially in C, C++, Java. So instead of writing step number 3 this way, what we will do is we will write this. Okay, we'll write this. Then at the end of step number 5, we'll write this. Okay. And now this step number 3, 4, 5 constitutes a loop. Now, over here, let's read step number 3. So step number 3 says, if I less than equal to 100, then execute steps 4 and 5, else go to step 6. The first thing which you should understand over here is that what you see in green color over here, green color, is a condition. It is a condition. Okay. So basically, ये जो green color है, this is a question which is being asked. And the question is I less than equal to 100? Now, if I ask you, is I less than equal to 100? What will be your answer? Use your common sense. Yes or no. Either you will tell me yes or you will tell me no. In terms of programming, we will say either you will tell me true or you will tell me false. So over here, if I less than equal to 100 is true, we will execute steps 4 and 5. And if it is false, okay, then we'll go to step 6. That is what it says. Okay. Now, one small simple thing, that when you write algebra, when you do mathematics, in mathematics, you don't write less than equal to like this. You write less than equal to like this, okay? But this is programming. In programming, we will write less than equal to like you see in green color, okay? So here onwards, don't write less than equal to like this, greater and equal to like this, okay? Now, what I will do is I will explain you how this new thing works, okay? Most of the things will be a repetition of what I taught you. So I'll go a little fast because I already taught these things to you, okay? So let's start. Sum is initialized to 0 and I is initialized to 1. So this is I and this is sum, okay? Now I is initialized to 1. Now for the sake of simplicity, let's assume that this is not 100. This is 3. So if I write 3 over here, then I will get the sum of first 3 natural numbers, okay? Now I'll ask you some questions and very quickly, very fast, you are supposed to answer those questions, okay? So let's start. Step number 3. Is I less than equal to 3? What is the value of I? Everybody. What is the current value of I? Huh? I repeat my question. What is the current value of I? The current value of I is 1. Look over here, 1. Okay. Sum was initialized to 0. I was initialized to 1. So I is equal to 1. So now, how to read this green color this way? Is 1 less than equal to 3? Now I'm asking you a question. Is 1 less than equal to 3?
True.
True or false?
True.
True. So I will execute step number 4 and 5. Now you already know step number 4 and 5. So in that, I don't need to spend time. So step number 4 says the new sum is equal to old sum plus I is equal to 1. And I is equal to I plus 1. So I takes the value 2. Now, after this, after I is equal to I plus 1, don't forget we have this thing, go to step 3. And this go to step 3 completes the loop effect. So now I go to step 3 and see, now this becomes a loop. Now, come on, this time, please answer the question. What is the current value of I?
2.
Is 2 less than equal to 3?
True.
True. Okay. So true, I will execute steps 4 and 5. So same thing, step number 4. New sum is equal to old sum plus I equal to 3. Okay. I is equal to old I plus 1, which is equal to 3. So I takes the value 3 now. Once again, the loop. So we go over here. Tell me what is the value of I now?
3.
Is 3 less than equal to 3?
True.
So again, execute steps 4 and 5. Be attentive. Many of you are going to do one mistake now. The new sum is equal to old sum plus I, which is equal to 6. The new I is equal to old I plus 1, which is equal to 4. Now, my question. Now, will we go to step 3?
No.
Yes or no?
No.
Yes or no?
No.
You are wrong.
Yes.
The answer is yes. And that is what I said. You will do the mistake. See, what happens is this says go to step 3. Go to step 3. Now, when we go to step 3, again we'll ask the question, is 4 less than equal to 3?
False.
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 False. Okay. So please understand one thing. Listen to this carefully. You will make this mistake later on also when I teach you loops. See, what happens is we will always go over here and we'll ask the question. Only after asking the question, you will get the reply yes or no. Okay. किसी लड़की का फोन नंबर चाहिए तो पहले तो उसको पूछोगे ना डायरेक्टली या इनडायरेक्टली कि भाई तेरा फोन नंबर क्या है. ओके, अपने आप तो जवाब नहीं मिलने वाला तुमको. So here also you need to ask the question, is 4 less than equal to 3? Okay, then you will get the answer no, the answer is false. So now if the answer is false, we are supposed to go to which step? Step number 6. We'll go to step number 6. So step number 6 says display sum. So now we'll display the sum which is equal to 6. All right. So this is how this particular loop works. Okay. Now I want you to copy 1 minute, just 1 minute. Okay, now you have written the word or. Now below the word or, what you do is you copy this algorithm, I mean the red color and the green colors from step number 1 to 7, and preferably draw this arrow also. It will help you. Okay, so come on, do that quickly. Increase your speed of writing. I give you only 30 seconds. Fast, hurry up, come on, be fast. Tell me one thing, while writing this, while copying this I less than equal to 100, did you use color? Did you use a different color? Yes or no?
Yes.
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 Very good. Now, listen, let me tell you something about colors once again. Okay, once again, this may sound unimportant right now, but it will help you a lot later on. See, if the first thing which you should always remember is that whenever I'm using a color, you should also use the color. Okay, so if I have given this condition in a different color, okay, if I am giving this condition in a different color, that means you should also give it in a different color. Now let me try to convince you, let me try to explain you what will happen, okay, if you're using a different color. So listen to me very carefully. Now what will happen is after a month or two, after 1 or 2 months, when you open your notebook, okay, and when you're going through this algorithm, you will see this condition I less than equal to 100 in a different color. Now when you see it in a different color, you will immediately recollect that this is the condition which can be either true or false. If it is true, it will go to so and so step. If it is false, it will go to so and so step. So what happens is only by using the right color, things will become very simple for you when you are referring your notebook the next time. And that is why I'm telling you to use colors. Trust me, it will make your life simple as far as CP is concerned. Anyway, now here onwards, what I'll do is many a times I'll dictate some small notes, okay? And these notes will help you in better understanding later on when you open your notebook, okay? So come on, give a heading note quickly. Okay, so under the note, you should write, come on, write. I less than equal to 100. That means this thing. I less than equal to 100 is a condition which will be true or false. Which will be true or false. If true, we execute steps 4 and 5. And if false, we go to step 7. Next paragraph. Steps 3, 4, 5. Steps 3, 4, 5 together constitutes a loop. Together constitutes a loop. All right, now let's go to the next question. Again, more difficult than the previous ones. Now, I'm sorry, this is not very difficult. Just copy the question. And while you're copying the question, in your mind, try to figure out what the question is asking you. Come on, copy the question. Write an algorithm to find the sum of first n natural numbers. And I hope you see that n is highlighted in a different color. So you should do the same thing. Okay, very simple. If you were paying attention, we can finish this in 1 minute if you are listening. Now, the previous algorithm was asking you for the sum of first 100 natural numbers, whereas this question is asking you for the sum of first n natural numbers. Okay. Now, once again, I will tell you the same thing, that if you want to become a programmer, if you want to develop your logic, you need to have what? What is it? Common sense. Okay, common sense. So now use your common sense and answer my next question. If somebody is asking you, please give me the sum of first n natural numbers. Please give me the sum of first n natural numbers. What is the first question which you will ask him?
Value of n.
Very good. You will ask him what is the value of n. So if he says that n is equal to 3, you will tell him it is 6. If somebody is telling you n is equal to 4, you will tell him it is 10. So now see what will happen is this much part of the algorithm will remain same. Okay. By mistake, this I is in uppercase, but when you copy it, you should copy it in lowercase. Okay. Anyway, this much part of the algorithm is same. Now, as this student told me that what you are supposed to do, you are supposed to ask the user for the value of n. So now we'll have step number 3. And step number 3 says read n from the user. Okay. And after you read n from the user, after the user gives you the value of n, come on. Now I have another question for you. Now we'll write a loop thing. If I less than equal to whatever. So can you tell me now we will write what? If I less than equal to
n.
N. Very good. So we'll write if I less than equal to n, execute steps 5 and 6, else go to step 7. And believe it or not, our answer is over. But wait, don't start copying. Once again, look at colors. Look at colors. Okay, because this is the beginning of our lectures. I'm stressing so much on colors so that you get used to it. See carefully. This n is in green color. This step number 3 is in green color. And this is in green color. Now, all this was done with a reason, with a purpose. ऐसा नहीं है कि मेरा होली खेलने का मन कर रहा है तो मैं अलग अलग कलर्स यूज कर रहा हूँ here and there randomly. नहीं, ऐसा नहीं है. Okay, if I'm using green here, green here, green here, it is for a purpose, for a reason. Just imagine a time 2 months later. Okay, let's say you are in the month of July, and in the month of July, when you see this question number 3, trust me, you don't even need to read the entire algorithm. See, before doing question number 3, obviously you will read question number 2. So when you come from question number 2 to question number 3, what will happen is you will realize, this is in green, this is in green, this is in green. So you will immediately realize that these are the only differences over here, and you don't need to read all this. And that's it. You'll finish question number 3 in 10 seconds. Whereas if you don't use these colors, what will happen is you will still realize this, but after reading the entire solution, and that may take 1 or 2 minutes. So basically, if you're using colors the right way, you end up saving lots and lots of time later on. Anyway, so now copy this entire algorithm and use colors as I told you. Okay, come on, be quick. The I in step number 5 should be in lowercase. Okay, let's move ahead. Now, copy question number 4, which is slightly difficult. While copying the question, try to understand the question. Come on, be quick, write a little fast. If your speed of writing is slow, then learn how to take screenshots of your screen. And when I go to the next question, just take the screenshot. Copy question number 4. All right, now let's discuss question number 4. It says, write an algorithm to find average of given n numbers. Please listen to this carefully. Things are different, things are difficult. Now, first understand the question. What is the question telling you? The question is telling you that over here, the user will give the program n numbers, okay? And we are supposed to find the sum of these numbers. And once we have the sum of these numbers, then we are supposed to find the average of these numbers. By the way, the question is not telling you to find the sum, but it is quite obvious that if you want to find average, you need to have the sum first. So once again, I tell you what the question is demanding. The question is telling you that the user will give you n numbers, okay? So after that, you will find the sum of these n numbers and you will give the average. So for example, let's say the user gives you numbers 2, 3, and 4. So all you will do is you will add them, you will divide by 3. Why 3? Because the user gave you 3 numbers and you will give the average, which is equal to 3. So that is the whole question. Okay, I'm sure everybody understood the question. Now, let's start with the answer and let's understand how this is different from others. So, as usual, step number 2 start. Here also we'll need variable sum because we want to find sum, and variable I. Now, why variable I? You'll come to know very soon. Now, I have a question for you all. You can unmute and answer my question. The question is, what is the first thing we will ask the user? Tell me.
What are the numbers and how many are the numbers?
What is the first thing which you'll ask the user?
How many numbers?
Very numbers. Very good. See, first of all, what we will do is we'll ask the user that how many numbers you are going to give me. Okay, that means you want the average of how many numbers. In other words, we will ask the user the value of which variable? Tell me. N. Yes, very good. We'll ask the user the value of n. So this becomes step number 3. read n as the number of elements. Okay. Now, one small simple thing, it is not necessary that you write step number 3 in this manner. Instead of writing step number 3 in this manner, you could have written take n, ask user for the number of elements and store it in n. Okay, you can use simple plain English. Okay, you can write any English like words the way you want. It is an algorithm. Anyway, so we are writing read n as the number of elements. Okay, in other words, n is the number of numbers. That way it is. So let's say n is equal to 3. Now another simple question, if n is equal to 3, that means the user wants me to find the average of how many numbers?
3.
3 numbers, very good. Okay. So now what we'll do one by one, I repeat, one by one, we'll take the 3 numbers from the user, we'll find the sum, and later on we'll find the average. So now I'll show you step number 5, 6, 7. First, let me write those steps and then I'll explain you. Don't worry if you don't understand them right now. So step number 5 will be this. Read x as the element. Step number 6 will be this. Compute sum equal to sum plus x. See, this is x, it is not I. And compute I equal to I plus 1. And then we go to step 4, which will control the loop. And that says, if I less than equal to n, execute steps 5, 6, 7, else go to step 8. I'm sure you don't understand 4, 5, 6, 7. So no problem. As usual, we'll draw a table to understand all this. So I will draw a table in which I will take variable I, okay, variable x, and variable sum. And as usual, variable sum is initialized to 0. Now, variable I is initialized to 1. Okay, some of you must be wondering what is this variable I used for? So you may understand it automatically, else obviously I'll explain. Now let's start. Okay, things are interesting but difficult, so be attentive. Sum equal to 0, I equal to 1. So I wrote sum equal to 0 here. I wrote I equal to 1 here. Read n as the number of elements. So let's say the number of elements is 3, which I'm storing in variable n. Now, I is equal to 1, n is equal to 3. Now, step number 4. Come on, answer this question. Is 1 less than equal to 3? Come on, answer. True or false?
True.
True. So execute steps 5, 6, 7. So now I go to step number 5. Now I want everybody to read step number 5 loudly. Come on, read step number 5. Come on, read it. Just read it. Come on. Okay, nobody wants to read it, so I'll read it for you. It says read x as the element. Read x as the element. अब इसका मतलब क्या हुआ? इसका मतलब ये हुआ that you will ask the user to give you one element. By the way, don't get confused with the word element. Instead of writing element, we could have written this way, read x as the number. So you will ask the user to give you one number, and whatever number the user gives you, that you will store in variable x. Okay. So let's say the user gives you the number 4. Okay, so you'll store 4 in x. Okay, so you store 4 in x. So that becomes read x as the number, read x as the element. Compute sum is equal to old sum plus x. Now this is very simple. I want you all to read it in the manner I taught you. Compute sum is equal to 8 plus 2 equal to 10, that way. So come on, tell me, compute sum equal to what?
0 plus 4 is
0 plus 4.
Very good. Equal to?
4.
Very good. 4. So the new sum is equal to 4. Then this says compute I is equal to I plus 1. So this is simple. I takes the value 2. And now it says go to step 4. So once again, we go to step 4. Now those who are paying attention, for you, this must have become simple. So now I'll go a little fast. Come on. Now, please answer the questions with me so that we don't lose the tempo. What is the value of I?
2.
Very good. Is 2 less than equal to 3?
True.
True. So now we execute step 5, 6, 7. So step number 5, read X as the element. Now let's say the user gives element 6. Let's say the user gives element 6. Okay. So now 6 will be stored in X. So basically X had the value 4, but now 6 will replace 4. Okay. So if you're paying attention, you will realize this X is storing the value which user is giving us. Now sum is equal to old sum. What is the old sum? 4. Tell me what?
Plus 6.
Equal to what?
10.
10. Okay. I is equal to I plus 1. What is the new value of I?
3.
3. Go to step 4. So once again we come to step 4. Now a little fast. Is 3 less than equal to 3?
True.
So once again, read X as the number. Okay. So let's say this time X is equal to 5. Okay. Compute. Come on. Read with me. Compute. M equal to
Plus 10.
10 plus 5 equals
equal to
15.
15. Very good. All right. I is equal to I plus 1. What is the new value of I?
4.
4.
Now one question which I had asked you earlier. Now, will we go to step 4?
Yes.
Yes.
Is 4 less than equal to 3?
False.
False. So now the loop stops over here. Okay. Now let's understand what we did till here. So if you're paying attention, what we did till here, we took 3 numbers from the user, and these 3 numbers were 4, 6, and 5. Okay. And we eventually found the sum. Eventually, we have found the sum of these 3 numbers, which is 15. Now, step number 8 is very simple. Okay. Can you tell me what will be step number 8? Very simple.
Display.
Very good. So step number 8. No. Sorry. Step number 8 is something else. Can you tell me what it will be?
Dividing step 6 by
Divide by n.
Divide by
Compute average is equal to sum divided by n. So it will become 15 divided by 3, which will be equal to 5. So average will be 5. And then you simply display average and you stop. So that was the algorithm. Now, before you start copying, wait, I have one question for you. Listen to me very carefully. Let's talk a little about this variable I over here. Okay. Now tell me one thing. Over here, listen to my question carefully. My question is simple, but many of you will not understand my question. Over here, are we using variable I for finding the sum, of the 3 numbers?
no.
Is variable I over here used as a part of the sum?
No.
No. Okay. Because if you look at step number 6 is very clear. It says sum is equal to sum plus x. Okay. So variable I over here is nowhere used in finding the value of sum. So then the question in your mind could be, then why the hell are we using variable I over here? I will obviously give you the answer, but can you give me the answer? Why are we using variable I?
To check the condition.
Very good. Variable I over here acts as a counter variable. Now, what is a counter variable? So, counter variable is a variable which keeps counting the number of executions of the loop. I repeat, variable I is a counter variable, which means it keeps on counting the number of executions of the loop. So if you see carefully, you will realize over here, see, I was 1. So that time the loop executed first time. I was 2. So loop executed second time. I was 3. Loop executed third time. And when I was 4, the loop stopped. So basically variable I is kind of controlling the loop. It is a counter variable. Okay, so I hope you must have understood this. Now what you do is, listen to me very carefully what I'm saying. You leave space in your notebook for this algorithm and for this working. Okay, you'll copy the algorithm and working right now. But first, you leave some space and write a note. Come on, write a note. Leave space for the algorithm, leave space for the working, and write a note first of all. Come on, write. In the above algorithm, variable I is a counter variable which helps us in counting the loop executions. I repeat, variable I is a counter variable which helps us in counting the loop executions. All right, now listen to me carefully. Now here onwards, in every lecture, I'll give you a break of 15 minutes. Why? Because I believe that in programming, things tend to get very difficult at some point of time and one really needs a break. So I'll give you a break of 15 minutes. In these 15 minutes, you should copy all this, okay? And then you can take a break for some time. Now, in my watch, it is 7:25. So we'll start strictly at 7:40. The meeting is going on. You will not leave the meeting. Okay. All right. So I will not admit you once again. Okay. So don't leave the meeting. The meeting is still going on. All right. So 7:40, we'll meet again. Look at the time in your watch. Okay. It will start sharp 7:40. All right, guys, we'll start in a minute. So wherever you are, just all right, guys. So now give the next heading B flowchart. Don't forget we are doing algorithm and flowchart today. So give the heading flowchart. Come on, give the heading. Now let's understand the definition of flowchart and then we'll study that in detail. Now, do you remember the definition of algorithm? So if you have come back, can you tell me what is the definition of algorithm? Come on, unmute and tell me. What is the definition of algorithm? Can you tell me?
English-like representation of a program.
Very good. An algorithm is an English-like representation of a program. Now, how do you define a flow chart? So a flow chart is a pictorial representation of the program. So in a flow chart, what we do is we use certain symbols. Okay, we use certain pictures. And with the help of those symbols, those pictures, those diagrams, we try to depict the logic of the program. So basically an algorithm and a flowchart both are one and the same. It's just that in algorithm, we use English language. In flowchart, we use certain symbols. So first of all, let's write a definition of flowchart. Come on, start writing, right? A flowchart is a pictorial representation. A flowchart is a pictorial representation of the program. A flowchart is pictorial representation of the program. All right. Now, let's try to understand the various symbols which are used in a flowchart. Now, you don't need to copy all these symbols. They are there in your printed notes and you have already written refer PN 8 to 13. So just pay attention. Don't write anything. Be attentive. Few things are difficult. Now, sorry. Now, if you want to depict start and stop in your flowchart, then for depicting start and stop, you will use a flat oval. So a flat oval is basically a rectangle whose corners are rounded. So if you see carefully over here, the corners are rounded. Okay. So basically for start and stop, we'll use flat oval, also called rounded rectangle. Now, what if you want to show input output? Okay. Now, I'll ask you one question over here. Listen to my question very, very, very carefully. Okay, you can unmute and you can answer my question. Tell me which step number in the earlier algorithm performs output.
Display sum.
Very good. So that
9.
display average, yeah, that display average or display sum, whatever it is, okay, that is basically output. Now, can you tell me in the previous algorithms, which step was input?
Read.
Very good. Read, not initialize, read. Okay. See, there is a difference between initializing and reading. So when we say initialize, we are giving the values on our own. Over here, let me do one thing. Listen. Now, let me talk about something very important. Okay. Once again, you see this algorithm in front of you. Now, whatever I'm telling you, it is a basic concept of programming. It is not about algorithm or flowchart or program. So listen to me very carefully. Here onwards, whenever I say that we will do this, you will do this, okay? That means over here, when I say you, when I say we means the program over here. We means the algorithm over here. So we are the programmers. We are the algorithm, we are the program, or we are the computer, that way, okay? Now, who is the user? The user is that person who gives us the input and who receives the output from us. Now, in order to understand this example, take example of ATM machine. In order to understand this concept, take example of ATM machine. Every ATM machine works on a program. I repeat, every ATM machine works on a program, okay? Now, when you go to the ATM machine will ask you to enter PIN. After that, you will type the PIN on its keyboard. So now I have a question for you. Listen to me very carefully. When you are using the ATM machine, okay, that time you are the user or the programmer? Come on, answer the question. User or the programmer?
User.
Very good. Very good. You are the user, you are not the programmer, because you have not programmed that ATM machine. The programmer is some other person whom you don't even know. So that way, a programmer is a person who writes the program, who has done the coding, okay? And the user is simply that person who gives input or receives output. So when we are writing this algorithm, the one in front of you, when you are writing this algorithm, the one in front of you, you are the programmer, you are the program, you are the algorithm, and the user is some imaginary person who gives input to this algorithm and receives output. Okay, so I hope this concept is very clear to you. You are the programmer, okay? You are taking input from the user and you are giving output to the user. Okay, so now, why I explained all this? Because somebody over here told me that that initialize step is input, okay? So please understand that when we initialize I to 1 and sum to 0, it is not input, because we are not taking the value of I and sum from the user, okay? We are giving I and sum a value which we feel appropriate. And once again, when I say we, I mean the programmer, okay? So which is the input? The input is that step where we read the value from the user. So wherever you see this word read or input, that is the input step, okay? Anyway, now, whenever you want to show input output in your flow chart, you will use a parallelogram. Now, inside parallelogram, you will write read X, okay, or display X, something like that, depending on the step. Now, once again, I have a question for you, and everybody can answer this question. You can unmute and answer. Instead of writing display X, if I write show X, is it okay?
Yes.
Yes, it is okay. But instead of drawing a parallelogram, if I draw a rectangle, do you think it is okay?
No.
No. So what I'm trying to teach you over here is that in flow charts, the symbols are more important. Okay. What you write inside the symbol, that can be changed, but the symbol must be same. Now let's go to the next category, which is called process. And many of you will make a mistake over here later on, so be attentive. Now, when we say process actually means two things. Whatever I'm writing in parentheses, you can also write somewhere later on. So process means either initialization or computation. So whenever you do any initialization or computation in your algorithm, okay, it is called process. Okay, so that step, initialize sum equal to 0, I equal to 1 is a process. Can you tell me which other steps are process?
6, 7, 8.
Can you tell me which are those steps?
Compute sum equal
Very
to
good.
sum
So
plus
wherever you, yes, very good. Wherever you see that compute, it is a process. And whenever you want to do a process, you will always give a rectangle. So inside the rectangle, you will write this. You may not write the word compute, it's okay. Similarly, you may not write the word initialize, it's okay, but it has to be a rectangle. Now, I want that somewhere you write this, that process means initialize and compute. Write it somewhere. All right. Now the next thing. So the next thing is decision. Can you tell me in the previous algorithm, which step is decision making? Which step is decision making?
Consider I equals to 1, that is initialize.
No.
fourth step. If
Can you
If
read
I
the step?
less than or equal to
if
n.
I less than
equal to
then
n.
execute
Very
step
good.
5, 6, 7, else go to step 8.
Very good. All of you, very good. See, now wherever you are using this thing, if I less than equal to this thing, then do this thing, else do this thing, that is decision. Because why? You are trying to make a decision over here, which step should I execute? Now, whenever you want to make a decision, what you will do is you will use a rhombus, also called a diamond. In the rhombus, in the diamond, you will always start with the word is. I forgot to write the word is over here. And you write is condition question mark. Now, every decision, every rhombus will have will have 2 exit points. And these 2 exit points will be true or false. So if this condition is true, we will do one thing. And if this condition is false, we will do another thing. Okay, you could have written true over here and you could have written false over here. It's okay, that does not matter. Okay, so every decision will have 2 exit points. After that comes the path, and the path is nothing but an arrow. So whenever you are drawing a flow chart, you will connect 2 different symbols with an arrow, and that arrow is called a path. If you don't understand this right now, don't bother about it. It's very simple. You will understand very soon. Finally, the last symbol which we are going to use is the connector. Now, the connector is always given inside a circle. And inside the circle, you can write anything, A, ABC, XYZ, anything. Now, how exactly this connector works, that you'll understand, not now, that I'll explain you later on. So except connector, I have explained you everything else. Now you all will write a question. No need of copying all this. This is there in your printed notes. Okay. So now directly copy this question. Come on, quickly. In 10 seconds, copy this question fast. All right. Now tell me, have we done algorithm for this particular question?
Yes.
Yes.
We have done the algorithm to find the maximum of 2 given unequal numbers, and that is this. Now what I will do is, looking at the algorithm, I will draw the flow chart. So I will draw a total of 2 flow charts, 2, and you will draw the third one on your own. Okay. So let's have a look at this. Okay. Don't draw right now while I'm explaining. Don't do anything. Okay. Listen. So step number 1 is start. So tell me, start is always given inside which symbol? Which symbol?
Rounded rectangle.
Rounded rectangle. So in a rounded rectangle, I will write start. Okay. Now step number 2. Listen to my question carefully. My question is simple, but listen to my question. In flowchart terminology, what is step number 2 called?
Input.
Very good. In flowchart terminology, step number 2 is input, and input is always given in which symbol? Yes. So inside a parallelogram, I will write this thing. I will write this thing. I will write read two unequal numbers. Read two unequal numbers as A and B. As A and B. Okay, I have written A and B over here. Okay. Now, I hope you remember on the previous screen, you saw something called path. So that path is basically an arrow which will connect two different symbols. So see, now I'll draw path from start to parallelogram. So this means first I will execute start, then the parallelogram. Okay, now in flowchart terminology, give me one word for step number 3.
Decision.
And decision is inside which symbol?
Rhombus.
Rhombus, also called a diamond. So inside the diamond, I will write is A greater than B question mark, and I will connect it with this path. Now every diamond will have how many exit points? 2. Every diamond will have a minimum, it will have 2 exit points. So let me write true over here. I could have written false also. And let me write false over here. False over here. Okay. Now answer a simple question. If this condition is true, I am supposed to execute which step? Display A. And display A is a process or a decision?
Output.
Huh?
Process.
No, it is neither a process nor a decision. It is output. And output is inside which symbol?
Parallelogram.
Parallelogram. So inside parallelogram, I'll write display A. Okay. And obviously over here also there will be one more parallelogram inside which I will write display. Tell me what display? What display? B. Okay. Now step number 6 is stop. Okay. Now tell me stop should be inside which symbol?
Rounded rectangle.
Very good. So inside rounded rectangle, I will write stop. Okay. It is a rounded rectangle. Okay. I'm using a pen tablet, so I'm not able to draw properly, but it is a rounded rectangle. Now, ये जो है go to step 6, ये जो है go to step 6. Okay. For this, what I will do, see, this is display A. So go to step 6 will be like this. See what I'm drawing. This is go to step 6. And this one, go to step 6. Okay. This is this. From here over here. So that completes our flow chart. Okay. This is the first flow chart. ये YouTube पे TVF का एक नया सीरीज आया पिक्चर्स PITCH. Have you seen that? Have you seen that? Anyone? All right. So why I mentioned about this is because it's very famous, and उसके episode 2 में there is a programmer who tells his wife कि आज मैं पूरा दिन एक flowchart बना रहा था कि how I'll talk to you. So that flow, if you ever see that, okay, you should recollect that the flowchart is nothing but this thing which is in front of you on the screen. Anyway, now very quickly, very fast, without using a scale, I repeat, without using a scale, draw this flowchart. Programmers should never use a scale. Come on, quickly draw this flowchart. Come on, hurry up, be fast. No, don't write the algorithm. You have already written the algorithm. The algorithm was only for reference. So below the question, you will draw the flowchart. All right, let's move on. So now copy the next question, only the question. This flowchart again I will take, but after that, the next one you are going to draw on your own. All right, so copy the question, everybody. All right, so the question says, draw a flowchart to find sum of first n natural numbers. Now we have already done this algorithm, and once again we'll convert the algorithm into flowchart. Now this time I want you all to be a little fast. Okay, so come on, tell me step number 1 will be with symbol.
Rounded rectangle.
So very good. So within a rounded rectangle, I will write start. Okay. Now, can you answer in flowchart terminology? Can you tell me in flowchart terminology, what is step number 2 called?
Process.
Very good. And process is always given inside with symbol?
Rectangle.
Rectangle. So inside the rectangle, I'll write sum equal to 0, sum equal to 0, and I equal to 1. You may or you may not write the word initialize, that is okay. By the way, you could have also given 2 different rectangles over here. So you could have given sum equal to 0 and below that I equal to 1, that is also okay. Come on, tell me step number 3 will be inside with symbol. Once again, tell me what?
Parallelogram.
Parallelogram.
So inside parallelogram, I'll write read n from user. Read n from user. All right. Step number 4, in which symbol?
Rhombus.
Rhombus. So inside the rhombus, we'll write is. Come on, tell me what we'll write is.
I less than or equal to.
Very good. Is I less than equal to n? Question mark. Okay. Now listen to me carefully. Can you answer in one word? You should answer only in one word. Can you answer in one word? What is step number 4, 5, 6 called?
Loop.
Very good. So now see how we develop the loop. If I less than equal to n is true, we should execute steps 5 and 6. So now what I will do over here, I'll write true. Over here, I'll write true. Okay. And if it is true, okay, I will execute step number 5. Now in flowchart terminology, what is step number 5 called?
Process.
Process, because it is computation. So I'll write sum is equal to sum plus I inside a rectangle. Okay. Similarly, the next thing also inside a rectangle. All right. So inside a rectangle, I'll write I is equal to I plus 1. I is equal to I plus 1. Okay. Now, very important, the next flowchart you're going to do on your own. So be attentive. Now, over here, you see go to step 4. Now, who is step number 4 in this flowchart? Who is step number 4 in this flowchart?
Rhombus.
Rhombus. Okay. So what I will do is I'll take a line from here. Okay. And I will take that line over here. Okay. And this completes my flowchart. So if you look at this, okay, I hope you can see this small dot. Okay. Now just follow this small dot. See where this small dot is moving. Okay. So if you follow this small dot, you will realize this is nothing but a loop. Now this loop will keep on executing as long as the condition is true. Now at one stage, the condition will be false. So as I told you, there will be 2 exit points and the second exit point will correspond to false. So now if the condition is false, tell me which step number will execute?
7.
7. And step number 7 is display sum, which we are going to write inside a parallelogram. So inside a parallelogram, we'll write display sum, and after that, stop. After that, stop. So, stop. All right. Okay, now wait, don't start copying, wait. Now, what you are expected to do, listen to me very carefully, okay? You are supposed to copy this flowchart. You are supposed to copy this flowchart. After copying the flowchart, you copy this question, okay? Or what you do is, listen to me carefully, leave a page for the flowchart, leave a page for this flowchart, okay? And after leaving the page for the flowchart, first copy this question. Come on. So everybody leave place for the flowchart and copy this question quickly. Do that. By the way, this will be question number 3, not 4. By mistake, I wrote 4. It will be 3. All right. So the question says that draw a flowchart to find average of given n numbers. The algorithm is in front of you for reference. Now, what you will do is you will copy this flowchart, and after copying this flowchart, you will draw the next flowchart on your own. Okay. So I give you a total of 5 minutes for all this. 5 minutes will be more than enough. Come on, your time starts now. Come on, start. Meanwhile, if anybody has any doubts about anything in the today's lecture, you can ask me. Sorry. All right, guys. So stop doing. Okay, just listen to me. Okay, and then afterwards you can make corrections. So everybody, listen. Now, while I'm explaining you, you will not make corrections or you'll copy in your notebook. While I'm explaining you, just pay attention. Okay. So over here, step number 1 is start. Step number 2 is initialize sum to 0, I to I. Step number 3 says read n as the number of elements. Step number 4 says if I less than equal to n, execute steps 5, 6, 7, else go to step 8. Now what I will do is I will make corrections in, I will do additions in this flowchart itself. So see, over here, what will happen is step number 1 will remain same, start. Step number 2, sum equal to 0, I equal to 1 will remain same. Okay. Step number 3 will also remain same, but maybe you can do one small change inside. Over here, you can just write read n as the number of elements. Read n as the number of elements. Okay, that is what you can write over here. Step number 4 will be same, is I less than equal to n. Now, if it is true, we are supposed to execute 3 steps over here. Okay. So, which are those 3 steps? Those 3 steps are 5, 6, 7. Step number 5 says read x as the element. Step number 6 says sum is equal to sum plus x. And step number 7 says I is equal to I plus 1. So, before I again change the slide, read these 3 steps in your mind. 5, 6, 7. Read them in your mind. Now, step number 5, read x as the element will be drawn inside which symbol? Tell me.
Parallelogram.
Very good. And can you tell me for 6 and 7 which symbol?
Rectangle.
Rectangle. Very good. So now what I will do is, okay, I will just try to insert a parallelogram over here. I'll try to insert one small parallelogram over here. Okay. So, all right. So if this is true, then I will insert a parallelogram over here. Okay. And inside the parallelogram, I'll write read x as element. Read x as the element. Okay. I don't have space, so I just wrote ELEM. So you will write read x as the element, and this is a parallelogram. And then again one arrow over here. Now inside this, I will write sum equal to sum plus. Tell me what?
Sum plus x.
Instead of I, we will write x. Okay. Instead of I, we'll write x. I equal to I plus 1 will remain same, and this loop will also remain same. Now, if the condition is false, we are supposed to go to step number 8. Now, step number 8 says, compute average is equal to sum divided by n. Step number 9 says display. Step number 10 says stop. So come on, tell me the symbol for step number 8.
Rectangle.
For 9. Parallelogram. For 10. For 10.
Rounded rectangle.
Rounded rectangle. All right. So see, now everything is over here. I'll just make some changes over here. What I will do is I will draw a rectangle over here, and inside the rectangle, I'll write average equal to sum divide by n. Okay. After that, the arrow, and over here, instead of writing display sum, we will write display what? Tell me. Average. And that's it. My flow chart is ready. Okay. So copy this flow chart, and if you have any doubts, you can ask me. Come on, start copying.
एग्जाम में से सब पूरा पेंसिल किया तो चलेगा ना?
क्या
एग्जाम में पूरा पेन से किया तो चलेगा ना फ्यूचर, या फिर पेंसिल से सब ड्रॉ करना पड़ेगा?
तुम्हारा आवाज क्लियर नहीं है, सो आर यू आस्किंग मी कि पेंसिल से ड्रॉ किया तो चलेगा?
तो अभी
आवाज आ रहा है बट बहुत ही नहीं ऐसा समझ में नहीं आ रहा है क्या तुम बोल रहे हो. आई कैन अंडरस्टैंड. Are you asking me that can we draw with pencil?
Yes, sir.
You can draw with pencil, but better confirm this with your college teacher, because every year na, the university rules keep on changing. So just ask your college teacher about it. Okay?
Okay, sir.
Okay. All right, now let's move on to the next question. I'm sorry, let's move on to some homework questions now. All right, now these are the two homework questions. Wait, don't start copying. The first thing which you need to understand, you should know, is that doing homework is not compulsory. That means even if you don't do the homework, it's okay. I will not tell you anything. But see, what happens is, as I told you one thing, that right now you will be able to understand what I am teaching you, but you will not be able to do these algorithms and flowcharts on your own. So for that to happen, your logic should be developed. And one way of developing the logic is to solve problems on your own. क्या होगा ना कि when you sit for the first time to write any program or algorithm or flowchart, what will happen is for 10-15 minutes you will sit idle, and nothing will strike you. And at that point of time, you may even give up. Okay. But that is the point when you should not give up. Okay. You try to solve as much as possible, and you will realize that if you're practicing regularly, okay, then slowly your logic will be developed. So for example, after 1 or 2 weeks, you will be able to write, let's say, the first 2-3 steps. After that, after 4 or 5 weeks, you'll be able to write, let's say, 6-7 steps. And that way, as time progresses further, one fine day, you will be able to develop the entire program or the entire algorithm. So that is the whole idea of solving the homework questions. If you have done the homework, I would prefer that you show me the homework before the lecture, okay? Or maybe during the break. And if that is not possible, then after the lecture. Now, over here, what I will do is I'll explain you the question, okay? I'll not give you the solution over here. So don't write anything, just listen to me carefully. The question itself is a little tricky, so be attentive. See, if you're not understanding the question, what will happen is you will solve the answer, but you will write the wrong answer. So be attentive. So it says, write an algorithm and draw flowchart 2. Find the sum of first n even natural numbers. Okay. So over here, as usual, tell me what will you ask the user? Come on, answer quickly.
And even natural numbers.
You will ask the user the value of n. Okay. So you will tell the user that give me the value of n. So let's say n is equal to 3. Let's say n is equal to 3. Now if n is equal to 3, you are supposed to find the sum of first 3 even natural numbers. Okay. So that would be 2 plus 4 plus 6 and that's it. You stop here. I hope you know these are the first 3 even natural numbers. So this is the first algorithm. Okay, any doubts about this one? Okay, now let's go to the next question, which is more trickier. The next question says, find the sum of all odd natural numbers till n. Now over here, you have to understand one thing. See, this first question tells you, the first question tells you to find the sum of first n whatever. And this question tells you find the sum of all odd natural numbers till n. So there is a difference when we say first n and till n. Now, once again, tell me for question number 2, what will you ask the user?
Value of n.
I'm sorry. What will you ask the user?
The value of n.
So let's say the user gives you n is equal to 13. So what you are supposed to do is you are supposed to give the sum of first, you are supposed to find the sum of all the odd natural numbers till 13. So your answer will be 1 plus, come on, dictate, come on, 1 plus what?
3.
3 plus, everybody. 5. Very good, everybody.
7.
7. Then,
9,
very good. Then,
11.
7.
very good. Then,
13.
13.
very good. Then,
13.
no, you stop here. You are not supposed to find the sum of 13 odd numbers. You are supposed to find the, I repeat myself, you are not supposed to find the sum of first 13 odd numbers. You are supposed to find the sum of odd natural numbers till 13. But wait, let me actually confirm that you understood. Let's say n is equal to 14. Okay. Now dictate me the sum. Don't tell me anything else. Just dictate me the sum. 1 plus, come on.
3.
3 plus
5.
5.
5 plus
7.
7 plus
9.
9 plus
11.
11 plus
13.
13 plus
That's
Nothing.
that's it.
that's it.
That's it.
See, you will not write 14 because 14 is not an odd number. Okay, and obviously you will not write 15 because 15 is greater than 13. Okay, so once again the answer will be same. Okay, so now quickly copy all this, and whenever I write any working, that also you should copy. So copy everything you see in red color, including what I have written. So come on, copy this. DJ Sangvi or VJTA students, are you attending lecture today?
Yes, sir.
What is your name?
Yashvi Satam.
Okay, anyone else? DJ Sangvi, VJTI, anyone else?
Yes, sir.
What is your name?
Lance Korea.
Okay, so DJ Sangvi and VJTI, you have the C++ also in your syllabus. So next week onwards, I think all the students will start attending lectures. There are many others also in DJ Sangvi and VJTI, but they are absent today because they have their exams going on. So after all the students join, I'll tell you the course of action which I'm going to take for C++. Okay. You guys have vacation? Yashvi and Lance, you have vacation right now? I mean, after your exams?
No, sir, I don't think so. Only 2 days maybe.
You are in which college, Lance?
DJ Sangvi.
And I think Yashvi also must be in DJ Sangvi.
Yes, sir.
So you have vacations after 28th?
They will start in June, maybe.
Mid-June. Okay.
Not told.
Okay. All right. So I hope this is over. Now, finally, if you remember, I need to explain you what a connector is. Okay. So I have not yet explained you a connector. So let me explain that to you. Okay. So just wait a minute. Just a minute, guys. I'll just explain you what a connector is. Okay, listen. So now listen to me very carefully, and you will write some notes in your own words. I'll not dictate you. I'm explaining you what is a connector and how it is used. So the name itself tells you that a connector is used to connect two different parts of a flow chart. Okay. So listen to me carefully. Let's say you start drawing a flow chart, and you are drawing a flow chart on a right-hand side page of your notebook. I repeat, you are drawing the flow chart on the right-hand side page of your notebook. Okay. So I will divide the screen into two parts. So let's say this is your right-hand side page. Okay. And when you turn this right-hand side page back, okay, when you turn it over leaf, तो उसके पीछे जो पेज आएगा वो होगा LHS page. Okay. Did you understand what I'm saying? Any doubts in this? Okay. So now let's say you start drawing a flow chart, and let's say the flow chart is very big. Okay. So let's say you write start. Okay. You write sum equal to 0. And that way you write many other things. So I'll just put dot ka matlab ellipsis. Ellipsis matlab there are other things which I'm not showing. Okay. And that way, let's say you reach the end of this page. Okay. Now, let's say the flowchart is still going on. It is a very big flowchart. Let's say the next symbol is something like this. Okay. I is equal to I plus 1. I'm sorry. Now let's say you have reached the end of the page, but the flowchart is not over. Moreover, now you are going to turn the page. So what you will do is you will put one arrow, and you will draw one circle. The circle is called connector. And inside this you can write anything, ABC, XYZ, your name, my name, anything. Okay. So let's say you write ABC. Okay. Now you flip over the page. Okay, you go to the next page. Okay, now let's say, listen to me carefully. After I equal to I plus 1, okay, let's say the next statement is something like this: read x, okay, which we write inside a parallelogram. So now what I will do is, after turning the page, inside the parallelogram, I will write read x, okay. But this read x is actually connected to this I is equal to I plus 1. So now what I will do is I will put one path over here, which will be connected to a connector, and over here I will write ABC. So if I write ABC over here, it means that this I equal to I plus 1 is connected to this read x, Now I have a question for you. Okay, you can unmute and answer the question. Instead of writing ABC here, can I write XYZ? Instead of writing ABC here, can I write XYZ?
No.
Others?
No.
We have to write same again.
We have to write ABC only. Because if you write ABC, then only it would mean that the two are connected to each other. Okay, so this is how a connector works. Very quickly, you can just draw this much and you can write some note in your own words. So I give you 1 minute for this. Come on, do that quickly. Okay. By the way, in your printed notes, I have given a few more algorithms and flowcharts. So for example, this one, okay, algorithm and flowchart to find roots of a quadratic equation. Then over here, flowchart to check whether the entered number is prime or not, okay, and this one to reverse a number. So these algorithms and flowcharts we'll do later on. Actually, at the end of the semester, I'm going to take something called LMR, where LMR stands for last minute revision, or whatever you say, last month revision, whatever it is, okay. So in that LMR, I'm going to explain you once again everything right from the beginning to end. So there I will take these algorithms and flowcharts once again. For time being, if you have these algorithms and flowcharts in your assignments, then you can use them from your printed notes. Okay. All right. So now with this chapter number 1 is over. I hope you remember that the name of chapter number 1 was Fundamentals of Computer Programming. So in chapter number 1, what we did is we studied fundamentals of computer programming, not the C programming. Okay. Now tomorrow we'll start with a chapter called C Fundamentals, where we will finally start with the C programming language. So tomorrow's lecture is going to be very, very, very important. But I have a quick question for you. Whatever I'm teaching you tomorrow, whatever I'll be teaching you tomorrow, tell me it will be used till which lecture? Come on, tell me. It will be useful till which lecture, whatever we are studying tomorrow?
Till the end.
Till the end, till the very last lecture. Because tomorrow we are going to study some fundamental concepts which are going to be used in every program. Okay, so tomorrow's lecture is going to be very important. Now, good news for you and a bad news for you. Which news do you want first? The good or the bad?
Bad.
Okay, so the bad news is that tomorrow I will take at least 15 minutes extra because the chapter is long. So I want to complete it in one session. I don't want to keep a gap of 1 week. So I'll take 15 minutes extra tomorrow, okay, from 6 to 9. And the good news is that today I'm leaving you early. Okay, so it's only 8:33, but I'm leaving you today. All right, so that's it for today. The meeting ends over here. You can leave the meeting, but those who have doubts, you can ask me doubts. Other people can leave the meeting. So any doubts? Any doubts?
Sir, will second chapter end by tomorrow?
Yes, mostly 99% second chapter will end tomorrow.
सर अगर दूसरे मतलब एल्गोरिथम्स मतलब प्रैक्टिस करने हो तो कोई बुक रेफर करना हो?
अभी ना कुछ मत करो फॉर टाइमिंग, और करना है ना प्रैक्टिस तो जो मैंने प्रिंटेड नोट्स में दिया है ना, उसका तुम क्या करो, खाली
वाला और वो,
हाँ वो क्वेश्चन देखो, सोल्यूशन मत देखो और वो प्रैक्टिस करो.
ओके सर.
ठीक है, ऑलराइट. Any other doubts? Yeah, tell me.
Sir, in earlier question we have taken I equals to 1 because of natural number starts with 1.
Correct.
But sir उसके next question में हमने I को 1 लिया था, तभी आपने नोट लिखाया था कि वेरिएबल I is the counter variable, तो उसमें I का रीजन क्या था 1 लेने का?
उसमें सिंपल है ना, कोई भी लूप पहली बार एग्जीक्यूट होता है, दूसरी बार होता है, तीसरी बार होता है. तो जब मैं बोलूंगा हाँ वो लूप को काउंट कर रहा है ना, तो I equal to 1 का मतलब लूप का पहला एग्जीक्यूशन है ऐसा.
ओके ओके, थैंक यू सर.
ओके, मोस्ट वेलकम. एनीवन एल्स?
सर प्रिंटेड नोट्स में फुल चैप्टर है ना, मतलब वो?
हाँ हाँ हाँ, प्रिंटेड नोट्स में फुल चैप्टर है. एंड तुमको मैंने प्रिंटेड नोट्स चैप्टर 2 तक दिया है. सो टुमारो आई विल गिव द एंटायर प्रिंटेड नोट्स टिल द वेरी लास्ट चैप्टर. एवरीथिंग आई विल गिव यू टुमारो. Any other doubts? Okay, so I'll end the meeting over here. Thank you very much.
Thank you, sir.
Thank you.
Thank you, sir.